welcome to another video. And today we're going to solve a new question called maximum consecutive ones 3. And in our last video, that is maximum consecutive ones 2, we solved it using prefix sum. And the same trick we're going to implement here, and we're going to derive the answer using prefix sum. In our last question, that is maximum consecutive ones 2, we took a k and we marked k as 1 because the maximum 0 we can flip is only 1. But in this one, k will be more than 1 because we can flip that many zeros edge of k. So this will be a little tricky, but we're going to implement the same solution as that of maximum consecutive 1 2 here to derive the answer. And here the k will be different, and the way we select the last 0 index, right, that will be a little bit different. So let's understand how we're going to derive it. So given that, let's take one example called nums, and nums is 1 1 1 0 0 0 1 1 1 1 0, and k is given as 2. So exactly the same way we derived our previous question, like max consecutive 1 2, we're going to keep calculating the prefix sum from index number 1. So this will be like 1 2 and 3. When we get our first 0, we're going to reduce our k by 1, k minus minus, and we're going to keep calculating and do it 4. And second one, when we go, we're going to calculating again because our k is greater than 0. So k will be 1 here, k will be so k will be 2 here. So we will reduce it, k will be 1 here, so we're going to reduce here. And when we go to the next value, it is 0, and our k value is also 0. We cannot reduce, so we have to calculate up to this point. And here our max consecutive ones will be 5. And second time when we have to calculate, we have to calculate from again the index number 3, right? Second calculation we have to make from the last first 0 value from here. So again we have to reset our k to 2, and we'll start calculating from here, um let's say again 1, then 2, and when we go to third 0, our 0 will become k will become 0, so we have to reset it, right? Then we again have to calculate from the second 0 here, the 1, then 2, so our k will become 0, k will become 1, k will become 2 here. Then we're gonna do 3 4 5 and 6. When we go to like this 0, our k is already 0, so we cannot consider. So for this index, our max will become max of 5 and max of 6, so 6. And third time we need to start calculating from this 0 again, right? So we're going to calculate again from that, or k will reset our k, to 2 again, and we're going to start from this 0. So what's going to happen here? It's going to happen like 1, and our k will become k is 2 in this in particular index, so you're going to calculate is 1, then 2 3 4 5. When you went to last index, again we can flip because our k will be more than 1, so we're going to calculate 6. But the time we hit our last index, that's the end of our calculation, so we don't have to calculate anything. And then we again compare this last value with our already existing max value, that is 6, so we get our answer 6. And you see in our question and right side, the answer is 6. So it's the same kind of solution that we implemented for maximum consecutive ones 2. We just have to little bit modify that for no k greater than 2, and we have to adjust the index so that we cover all the zeros. One important thing that this is not the most efficient solution, but this works because this is easy to understand using prefix sum, and this works. There is some efficient solution that I find. I did not come up with the solution. This one I derived because using prefix sum, but the solution that is very less code is little bit tricky, and it is efficient. We're gonna do that later, but let's solve it using prefix sum, which is easy to understand and also works. So now then, let's implement the same using JavaScript. So we will have first in step 1, uh, let's create variables, right? And then we can get our zero index. Again, this step, when I gonna do it, I will say why I did in that way. And then S3, we can count the ones using prefix sum. So let's create our variable. Definitely we need one variable here. We already have k, so let's assign k to a variable k so that we're gonna keep decreasing it and reset it, right? And then let max, we're gonna have first max, let's create 0, and then we need a variable called running sum where we're gonna adding and calculate our sum. So let running sum equals to 0. Let length equals to nums dot length. I think that's that. And now now I will create a stack, right? And what I will do is I will keep the indexes so that we can do that in the same for loop, but that makes it more complicated, and this makes it more easy to understand. So I will keep track of all the zeros from the right side of the array, so that when we pick one, pop one of those, we'll get the indexes from left to right. So I will traverse the array from right to left and save the zero indexes, so that in our calculation when we pick one of those, like pop of1 operation, and I will get indexes from left to right. So that's what I'm going to do here. So for let I equals to len minus 1, I greater than equals to 0, I minus minus, if not nums of I, then stack dot push I. So this will do the trick. Means I will put the indexes from right to left in a stack so that I can access those in OF1 time. Now we're gonna write our prefix sum logic. So for or we can do a while loop, like while I. So let's create I here. Let I equals to 0, while I less than len I plus plus, right? And now, first thing first, if nums of I means if we get a 1, we just have to increase our running sum. So running sum plus plus, right? If so this is our prefix sum, right? This is the prefix sum. Why it is prefix sum? Because we have value 1, so we keep adding 1. So if there is different value, we have to do it like num of I plus num of I minus 1. But here, since the value is only 1, we can increment it just using plus plus. So now the second thing comes, if k is what, less than 0, sorry, less than sorry. Mm, okay, if k is less than, no, greater than 0, means we have more zeros to flip, and we have to make it else if and nums of I, we can write like this because the value is 0, so you don't have to compare it to a 0. You can just write not nums of I. Again, we can use running some plus plus as usual because we're going to consider that 0 as 1, right? And when we consider 1 0 as 1, we have to reduce our k. So we may have to make k minus minus. Else, if k equals to 0, or we can write not k and not nums of I, it means k becomes 0 here and nums of I 0 here, also 0. Then we have to reset everything because we cannot flip our 0 to 1. So here we have to do our running sum equals to 0. We're going to reset our k to again k, means the original value, and we have to move our I index to stack dot up. So we have to just again keep calculating from the a 0 values, and yeah, and we have to again here we have to keep track of our max equals to math dot max and running sum, and the end we just have to return max. And this should solve our problem. Let's try it. It solves. Now let's submit it and see. Test cases are accepted, and now I'm submitting it. So you see it works, but it is like one of the least efficient one because we used prefix sum ofn operation, and second time in worst case will be ofn square. If the last one goes, everything is 0. So we solved it using ofn square actually, but it can be solved with ofn. And let me show what they did in ofn operation. So now let's discuss how the efficient solutions solved this particular problem using OFN operation. Okay, so let's consider the example number 1. Nums equals to 1 1 1 0 0 0 1 1 1 1 0. So we're going to start our loop from I equal to 0, right? Let's write down the indexes: 0 1 2 3 4 5 6 7 8 9 10. Okay, so we're going to start from index number 0, and we're going to traverse through the array from left to right. And at that time, we're going to keep counting. Let for I equals to 0 to I will go up to 10, right? So for every time, we're going to count. If num equal to 0, right, we're going to keep counting our number of 0. Okay, let's consider it as z count. Okay, at the first time we're gonna get 1, so we don't have to do anything. We just keep incrementing it, our pointer 1. Then our I will go to our first pointer, another pointer. We're gonna create j will stay at 0. We don't have to do anything after that. Okay, then our I pointer go to 2. Then I will go to 0. We encounter the first 0. At that time our 0 count will become 1, right? 0 count become 1. And if our k is less than 0, because the time we encounter sorry, a 0, our z count increases. So our maximum k is here 2. So we just have to consider if our k count is less than our 0 count or not, right? If less than 0 count, then we have to see if we already have a 0 before or not. Okay, we'll see. We already have a 0. It means j means this num sub j, that is 0 pointer, is 0 or not. If we get a 0, it means we have to. So if our j pointer, is at value is 0, it means we already got a 0 before, and our k pointer is already become uh, larger. Our k pointer will become larger when it goes to pointer number index 5, right? Our k will become less than 0 for index 5, and at that time we'll consider it our j pointer. Do we have another 0 before? No, we're not going to find it. So we're going to keep increasing it anyway, so our j will become 1. Same way again for next one, our I will go here, right? Again for this one, our k counter will be stay less than 0. So again we're gonna increase our j to 2. And for next time, when our j counter will go to 1 7, we'll find here our k will become less than, anyway k will become less than our 0 count again. But here we're going to get our z count become 0, so we already have a 0. So what we're going to do, we reduce the 0 count by 1, minus 1, the same 0 count by minus 1. Again we're going to keep increasing our j plus plus no matter what. So our j plus plus now will go to 4 index. And same way, by the time we reach the last index, our z index, j pointer will be at 5. J will become 5, and we just have to return the length of the array, that is 11, minus the last index that we are, j, that is 5, and it will give us answer 6. That's the same thing. How it works, hope you understand it. But let's it's just counting the zeros, and if you get the k number of zeros, it's checking we already have a 0 before or not. If we already have a 0, it's reducing the 0 count. If not, it keeping the zero count and it increasing the k as a left pointer to right. So at the so at the point when we reach the end of that array, our j pointer will be at the correct position. By flipping how many zeros we need, that index will be in correct position, and it just subtracts that index value from the length, and it um, returns the what result. Now let's try to implement the same using JavaScript. So we're going to create another function. So let's rename this function to old, right? Old, and so that we can use the same test cases, nums. Okay. Okay, here, first we have to do the variables, that is let jet count, right? Jet count equals to 0. Then we have to run our for loop. For let I equals to 0, I less than nums dot length, then I plus plus. First thing first, if nums of I means not nums of I, that is, means it's a 0, then we have to increase our jet count by 1, right? Jet count plus plus. Then we have to check if k is less than uh, jet count. It means we already flipped the number of zeros. So then we have to check our last pointer. So we're gonna let left equals to 0, right? Or we can call it j equals to 0. If nums of j equals to 0, it means we flipped k number of zeros and we already have 0 before. Then we have to reduce our jet count by 1, and we just have to keep increasing our jet count, j count, and at the end we just have to return nums dot length minus j. That's all. Now let's run it and see if it solves. So now let's submit it and see if it works. Let's run it. It works. Now submit. You see, this is the efficient one. So that's that, and see you in our next video. Thank you for watching.